Hi everyone, this is Final Exam Review, but this is going to be video part 2. So we're here on the logarithms. So we're going to solve these logarithm equations. These are very important, but we didn't have enough time in class in February to help the kids who didn't get it. So there's two rules here. There's actually 3 log rules. Let's write it up here. If you have a logarithm plus another logarithm, that equals 1 logarithm with the 2 inside terms called the arguments are being multiplied, okay? And if you have the log of A minus the log of B, then those combine into a single logarithm by division, with the first argument going in the numerator and the second argument going in the denominator. So we need these 2 rules. So that's going to be step 1. Step 1 is that we have 2 logarithms and we need to combine it into 1. So on 16, it'll be division. On 17, division. But on 18, you see the plus sign. So what's it going to be? If you have a plus sign, we're going to multiply. So I'm going to go over 17. Okay, we're going to combine step 1 right as a single log. So we're going to have the ln, natural log, of 5x squared plus 4 divided by 10. And that's going to equal 3. You have to memorize the steps right as a single log. Okay. Now that we have a single log equal to a number, we're going to use the inverse operation of log. So what's the inverse operation of log? Inverse of ln is e. So it's e of both sides. So watch how that goes. We take the e of the left side and the e of the right side. And anytime ln and e are touching, you say, hiya, karate chop, and those cancel each other out. And we have 5x squared plus 4 divided by 10 is equal to e to the power of 3. E to a 3 is a number, irrational number, and it's in the calculator, but we're not going to use the calculator at all. Okay? So from here, we got to get x by itself. So, I mean, that was the goal from the beginning, get x by itself. But watch from the beginning. We had to get rid of the 2, the 5, the 4, the ln, and that 10 somehow. Okay? So we got rid of the ln. Congratulations. And now we still have to get the x by itself. So we have to inverse operation, the square, the 5, the plus 4, and the division by 10. You ready? That's 4 things. We can do it. What's the first thing we get rid of? The first thing we get rid of is the division by 10. So how do we undo division? We're going to multiply. Multiply both sides. Okay? 10 divided by 10 is 1, so it divides out. So now we have 5x squared. I don't need the parentheses anymore. Plus 4 equals 10 e to the 3. What's next? X by itself. We have a 2, a 5, and a 4. What do we get rid of next? The 4 minus 4. Do you know what 10 e to the 3 minus 4 is? I don't either. I don't know. So I'm going to leave it. You just leave it separated out. 10 e cubed minus 4. All right, what's next? Division by 5. Division by 5. Here we go. 5 divided by 5 is 1. Now we have 1x squared equals 10 e to the 3 minus 4 all over 5. Last step, final step. We have an x squared. How do we undo the square? Square root. We're going to take the square root of both sides. Okay, so we took the square root of both sides, and I had to get another piece of paper. It's going to be, say, x equals plus or minus. How do you take a square root of a fraction? You do the square root of the numerator over the square root of the denominator. And then we're going to rationalize the denominator. Are they all going to be this lengthy? No. Okay, why did we rationalize the denominator? Square root 5 times square root 5 is a 5. And then it's been a while since you've done this, so I'm going to remind you, you can multiply a square root times a square root. You can't add 2 square roots together unless they're the same, but you can multiply like this. So we're going to end up with the square root, finally, the final answer, 10 times 5 is 50 e to the 3, and then 4 times 5 is 20. So minus 20. Like that. Check the answer. 17. Positive, negative. Fantastic. Okay, how did this all begin? You should have known how to do this, and this, and this, and this, and this, and this. And E is easy on both sides. It all started with this one silly step of the log rules, the 2 log rules. Okay, so make sure you have those easy rules because the rest is review of like things that you knew from prior years. Oh my gosh. Okay. I love these. Did I skip one? We're okay. 17, 18, 19. 17, 16, 17, 18. I did skip one. These are... Hi. Sorry. Here we go. Sorry about that. Crazy. Identify the holes, the vertical asymptotes, the x-intercepts, horizontal asymptotes of each. Holy moly, what the heck? Do you remember any of this? Here we go. You can watch other videos for review. But a hole, how do you get a hole? A hole is when a factor cancels. C-A-N-C-L-E. How do you get a vertical asymptote? It's when a factor doesn't cancel. So it's a factor in denominator that didn't cancel. X-intercepts comes from the factor in the numerator. And then the horizontal asymptote. Ready? Horizontal asymptote. If you have small over big, do you remember this? The horizontal asymptote is equal to 0. If you have same over same, the horizontal asymptote is the ratio of leading coefficients. Ratio of leading coefficients. And I'm not sure if we have a big over small. It's infinity. Big, no. Okay. Do you remember these factors? Remember this? So if we have, well, let's talk about 19. You're supposed to factor first, but there's nothing to factor here. Okay? So if there's nothing to factor, did any factors cancel? No factor cancels, so there's no holes. Vertical asymptote. What's in the denominator? X. So our vertical asymptote is when x equals 0. The x-intercept comes from the numerator equal to 0. So we set the numerator equal to 0 and solve for x. What would x equal there? And the horizontal asymptote is same over same. Do you see how it's x over x? So our horizontal asymptote is the ratio of leading coefficients. So what is the ratio of leading coefficients? What's negative 3 divided by 1? So this would be that. Okay. I don't want to give it all up. So this one would be factor. How do you factor? I feel like I have to do all of these to explain it all. Factor. Okay. Do you agree that this factor would cancel? Yes. So if that factor cancels, then that means you have a hole at x equals 0. But then we have to factor this denominator again. So did these factors cancel like that? Did these factors cancel? No. So what do we do with the factors that don't cancel? Those are going to be the vertical asymptotes. So we're going to have a vertical asymptote at x equals 3 and x equals negative 2. I'm going to do this one all the way. Okay, identify the holes. We have a hole at 0 because x over x cancels out. Vertical asymptote comes from the factors in the denominator that don't cancel. So both of these would give our denominator 0, which would give us a vertical asymptote. Okay, an x-intercept is when you set the numerator equal to 0, but then there's no x. Today is eraser day. There is no x-intercept because there's no x value to solve. Okay, horizontal asymptote. You ready? Is it small over big or same over same? Look at the powers. So this power of 1 over power of 3, that's small over big. So we have a horizontal asymptote at 0. Okay, that's why there's no x-intercepts, right? Oh, yeah. Okay, so there's our horizontal asymptote. Let's see, a vertical asymptote at 3 and a vertical asymptote at -2. We have a hole at x equals 0. Okay, how do we find the height of that hole? You have to plug it in. You have to plug in. So we have 0 plugged in, and that would be 4 over -3 times 2, -6, which is -2/3. So we have a hole at 0, -2/3 here. Okay, how do you graph the rest of it? That's where in class we kind of ran out of time on this topic. How do you graph the rest of it? Okay, go to the left of the asymptote, -3, and then go to the right, and we're going to plug in these x values, but we got to skip over the asymptotes. So what would the y value be if we plugged in -3? It would be 4 divided by -3 minus 3 is -6 times -1. So that'd be 4/6 or 2/3. So there's a point at -3, 2/3. So this piece looks like that. I don't need any more points. I already know. Okay. -1. If I plug in -1, I'm going to get -4 divided by -4 divided by -4 is -1. So -1, and this is going to look like this. I'm pretty sure it's going to go down, but I'll plug in these points. So 4 divided by 1 minus 3 is -2, and 3. Here we go. What's this going to be? -2/3 again. It's like a popular coordinate point. Okay, when we plug in 2, I get 4 over -1. 2 plus 2 is 4, which is -1. Okay, so I was right. It does go down like this. Okay, one more point. We're going to plug in 4. So when we plug in 4, we get 4 divided by 1, 4 plus 6, 2/3 again. Oh, but it's positive. So 4 2/3. Holy moly, that was a long one. All right, I'm going to leave the rest for you guys to practice, and maybe you need to go look at your notes to review some more. But this is called graphing rational functions. Okay, I was so excited to do this earlier. Solving equations. Again, we got to get the x by itself, so we have to undo all these things. You ready? Here we go. Let's add 1. What are we going to do with this -4 next? -4, we're going to divide by -4. We're adding 1 to a negative number, so it's going to get less negative. Okay, divide by -4. Negative divided by negative will be positive. And what's 4? How many times does 4 go into this? I'll do long division. 4 goes into 17 4 times. 4 times 4 is 16. Minus 1. Bring down the 2. 4 goes into 12. Oh, look, 343. 343, that's a special number. 343. We should know what that is. Okay, do you see this rational power? In order to get rid of it, we're going to raise both sides to the 2/3. So I'm going to raise this to the 2/3 power, and it would cancel. So now we have 49 is equal to, do you remember how to do this? We're going to take the cube root of 243. So what is the cube root of 343? All right, the cube root of 343 is 7. So now we have 7 squared. So 49x equals 49. So x equals 1. This is a review of the solving trig equations, which was lesson 8.6. I have 10 seconds, and we'll have to make another video to finish. Sorry about that.